Do you think these techniques can be and should be applied to coding agents over time?
With coding agents, there's always going to be a trade-off between how easy it is to use and how secure they are. It's very convenient right up until it does something terrible to your production database. As you get into more and more secure enterprises, there's going to be less and less tolerance for this sort of convenience and the associated risk.
You don't have to look very far to find stories about agents doing weird and unexpected things. Now, we're not talking about odd answers or hallucinations in a chat window. We're talking about where agents are doing real work. They're reading private context, calling tools, changing files, using credentials, and touching production systems. Now, here's the thing. Some of these examples are actually quite dramatic. If you see what they've actually done, they've deleted databases, changed cloud environments, exposed sensitive data. And they followed hostile instructions that are embedded in code, documents, or repositories. Now, these incidents get attention because they're easy to understand, but they also have huge impact. They impact real enterprise processes, and we need to get this under control. But the very first question you actually have to ask yourself is, which agent actually did the harm? Now, answering that question is a little bit more than taking a look at a log file. Fundamentally, we believe it starts with agent identity. Now, as we talked about in the last episode, there's three segments to this entire discussion. The first one, which we talk about today, is about agent identity. What is it? Why is it important? But it also ties into things that we can now do with an agent identity. We can create an authorization boundary that defines what an agent can do. And we can create an execution boundary that ensures that an agent can only do what it is authorized to do. So as I said, this discussion today is about the first layer, agent identity. My name is Eric Broda.
And I'm Davis Broda.
Welcome to the Agentic Mesh podcast. So, Davis, where should we actually start on this discussion? Tell me where you want to go with this.
Well, I think we need to start discussing how things are currently going and why a lot of agents don't have the sort of distinct identity we think they're going to need in the future. Fundamentally, that's because most current agents are personal agents. They are coding agents. They're things like Claude Code or Codex. They're things that a user is using as an assistant to them, which means that the agent identity isn't really an identity of an agent. It's instead inheriting the identity of the user who is using this agent. So when an agent is accessing a database, it's going to be recorded as this user, this developer, is accessing the database, and those credentials are going to be used. And this way, you can effectively track down which agent did it by simply looking for the developer and saying it was their agent that made a mistake. For personal agents, this at least sort of works, but we're envisioning many, many more agents embedded in business processes, and these agents being headless. They are not going to have a dedicated user that could simply inherit the identity from. They're just going to be agents operating on their own in response to incoming messages or automated requests or anything else. So they aren't going to be able to have this same sort of inherited credential that lets them be tracked down at the end. They're going to need something of their own.
Absolutely. So what we're talking about is today, when people talk about agents, they really are talking about coding agents or personal agents. And these agents run literally on your desktop, on your Mac Mini. And what that really means is they're using your identity. And by virtue of using your identity, they have access to your passwords potentially, maybe even the secrets or the environment variables that are defined some of the access keys. What it means is that these agents are doing anything and everything that you can do, and maybe even more. If they have access to Bash, or if they have access to the internet, they can do just about anything. Now, as I mentioned, there's a few horror stories that have occurred. You can read them on the internet. The reason these things occur is because the permissions and the capabilities of the way those agents weren't governed. And the way that we're going to address that is by giving agents their own identity. They will not inherit the identity of a user. They'll have their own identity. And when they can do that, is they will be able to be full participants in a workflow, in a business process. As you mentioned, Davis, this is if once agents are embedded in business processes, there is no user that is watching over them. There is no user interface that a person can actually control the agent. There is obviously an opportunity to have human interaction with it, but fundamentally, these agents operate on their own, accessing sensitive data, potentially doing things that could have large impact and a large blast radius when they don't work. So first and foremost is in a world where we're going to have many agents and they're doing real work in embedded as they're embedded in business processes. What we need to do is carve out a unique identity for every single agent. Now, Davis, tell me what an agent identity actually looks like.
Now, that's a very good question. An agent identity is effectively a unique identifier that belongs only to this particular agent and only to this particular instance of an agent. And this may sound like a very nitpicky distinction, but it's actually very important, especially in cases where you have a bunch of agents doing the same thing and you run into load balancing concerns where you may have met multiple copies of an agent that have identical configuration. Each of them will still need a distinct identity, a distinct name effectively from those other agents. And once you know that this name, this ID, this potentially UUID is globally unique, it's the sort of thing that you can build on from there. Once you have a unique name, you can start doing things like attaching keys so that people can verify that a message is coming from who it says it is. You can start attaching credentials to it. You could start using this name in logs and auditing systems to keep track of everything that the agent is doing so that whenever something goes wrong or someone's investigating something, they can always track it back to the specific agent, the specific instance where something actually happened. So you know that if you're looking at agent 1 UUID, whatever, you can always pull back and say, it is this specific machine and this specific instance on this specific VM where this event actually happened, which is very useful for all sorts of purposes. Of course, that does bring up the question of what does it take to secure an identity?
Hmm. Well, let me come back a bit. So what you're saying is that there is a unique ID, identifier for every agent, a canonical agent ID. And once we have that, there's a whole bunch of things we can layer onto it. We can, for example, have a human readable name so that, whatever that canonical identifier may be, a person can actually understand what it is and who that agent is. We probably can attach a version because there may be, an agent may evolve over time. We can attach a owner. We'll know who's accountable for that agent. And then, as you mentioned, we can actually attach credentials. So you'll be able to participate, for example, in OAuth 2 flows. You'll be able to actually use your identity to get access rights to potentially data. We're going to be able to use that agent ID for auditing and logging and problem diagnosis. So the agent ID is fundamental and foundational to having agents actually participate broadly in business processes and within the enterprise. Now, I want to talk a little bit about where do you get this agent identity? I know there's products like Keycloak, for example. There may be an identity book of record. If you're working in a bank, they probably have multiple ones of those. How does an agent actually get its identity?
An agent identity is going to have to be assigned to it by someone with the authority to do so. If this agent is being created in a somewhat manual process, then this identity might be assigned by the person creating it who has the authority to do so, and then implicitly uses their credentials to create the identity in whatever book of record system is being used here, whether it be Keycloak or OAuth or some other system. As you scale up, however, you're going to end up with processes where agents need to be created in response to conditions that are automatically detected so that they can be spun up and taken down as needed. In this case, you're going to need another system component that has the ability to create IDs within certain parameters and assign these to agents, along with getting them whatever keys and minimal credentials are necessary to get them spun up, and actually get these IDs in place to register the unique names, make sure the names are unique, and ensure that these names are known to the agents who are using them so that they know who they are and they can use everything else attached to that identity.
Now, Davis, this sounds like an employee onboarding process. So, let's explore this a bit. I know the analogy of an agent to an employee runs out of gas relatively quickly, but for the purpose of this discussion, let's explore how an employee onboarding process is similar to an agent onboarding process. Tell me what your thoughts are on that.
Yeah, this is one case where the analogy holds reasonably well. When you get a new employee, when you're bringing them on board, you need to evaluate them to see if they're fit for the task you are going to give them. You do an interview, you look at their credentials. Maybe you call up some of the references to see if they've done a good job before. And these are all things that you're going to continue to do or do equivalents for when you get agents. You're going to look at other people who are using the model. Does it work for them? You're going to see, does the model have a good history of past performance? Does it do well on whatever standardized tests are being run? Are there any certifications this model has that someone says that it's fit for purpose? Are you doing your own security review on it, analogous to like a background check in an employee, to see if there are any known issues that you'll need to go around? And even beyond that, you're also going to figure out what purpose a given model is fit for. Because some models are very high cost comparatively, in that a given set of tokens will consume a reasonably large amount of dollars. And there are tasks where the performance guaranteed by that are going to be useful. There are other tasks where high performance is as important, and you might want to go with a cheaper model that can get a lower token cost. There are some cases where you're going to be okay shooting data across the network to a remote server, like, say, OpenAI's ChatGPT or Claude for Anthropic, and other cases where you're going to want a local LLM running on your hardware so that you can ensure data does not leave your perimeter. And when you put all these together, you get something very analogous to an employee evaluation or an employee onboarding and hiring process.
I love that. So what we're saying is that uh, the analogy to an employee actually has multiple dimensions. So first off, the onboarding. What I'm hearing is just like when you're hiring an employee, you have a job description that says what do we expect the employee to actually do, what skills are necessary, background, what security clearance they may actually need, which may dictate which checks they actually may need to go through, background checks, etc. Same thing for agents, where we would look at a particular agent and we'd say, maybe we need a reasoning one, or perhaps we don't need, we need an agent that does not have that powerful capability. Maybe we have a simple task. Or we may have, and this is where the analogy starts to break down, but an agent may have criteria that says, hey, I want a low-cost agent or I want a high-cost agent, which is commensurate with the scope and requirements of the task. Maybe I need an agent that can access or do processing locally on my data center platform as opposed to on the cloud. So there's a variety of different criteria that you would look at when you're thinking about an agent. Now, you also said that as an employee does its work, or at least the analogy is an employee does its work, there's an opportunity to assess that whether that employee is doing a good job or not. Same thing with agents. Now, the other part of this, which you didn't mention, but I'll add, is there's a situation where employees may leave a firm. And when that happens, you need to have an offboarding process. And that offboarding process says that identity is decommissioned. Now, that may mean disabling the employee account, but though the employee ID still remains because it relates to audit records or other things that may need to be kept for long periods of time. Same thing for an agent. Am I tracking correctly here, Davis?
Yes, you're definitely going to need an offboarding process in order to ensure that agents are properly taken down while their logs are maintained for future auditing or investigation purposes. However, there's even more to that process. Presumably, this agent is being used because it's doing some sort of task that's important to the business. So just like if an employee hands in their 2-week notice, you start looking for a replacement, you're going to need to figure out what the processes the agents are doing, what's going to happen to them when you decommission that particular agent. Is there a successor agent you're going to be handing them to? Or is this a task that you've decided is better suited to human employees, in which case you need to onboard them? There are a variety of things that can happen when an agent goes away, but it's rarely, except in perhaps the cases of an absolute emergency, it's rarely going to be the case that you just kill an agent and there's no lead up to that.
Hmm. Now, I want to come back to one question. We talked a little bit about the products like Keycloak as a repository or the book of record for identities. Um, we tend to use HR systems typically for the book of record for employees. And while the systems that we use for an agent identity may be slightly different, there's a lot of similarity. So let me give you a few examples. In a bank, we may have multiple identity books of record. Maybe one for this particular region. Maybe there's a book of record for Europe that adheres to particular privacy regulations or whatever the case may be, unique to Europe. There may be a different one for North American operations. There may be a different one for Asian operations. Fundamentally, what we may have is multiple books of record. I anticipate something very similar for agents. So what that means is that we may not have that single unifying book of record, but rather that identity book of record for agents is probably going to be mimicked or even mirror some of the constraints that are imposed on employee books of record. So for example, we may have agent books of record in Asia. We may have different ones in Europe. Do you foresee that having significant technical issues, Davis? What are your thoughts on that?
Oh, this is going to have a considerable technical impact. With an employee, you can send them on a plane halfway around the world if they need to go do something there, and you could send along the paperwork, but ultimately there's a person there who can basically say, "Yes, I'm me. I have the IDs," and who can talk it over with people. But you're not going to have that sort of ability with agents because, well, an agent can't really speak for itself, or at least is generally not going to be trusted to do so. It's simply not a person. So that means that an agent is going to either be very heavily limited to operating within the region where its book of record properly exists. For instance, a European agent or an agent with an entry in a European only book of record can only really operate in Europe. Likewise, one in North America. And if you need to get an agent to a different system, you're either going to have to deal with the whole process of getting that agent's information into the second book of record and then ensuring that those remain in sync, or effectively creating an entirely separate copy of that agent in the other book of record and then letting them potentially diverge from there, depending on the different needs in the different areas. And sometimes this may be desirable. For instance, Europe has GDPR and other very sensitive and important data handling regulations. So it might be very good reason to have an agent that's restricted to, say, Europe only and simply can't operate outside of there. That would ensure that you can't process the things in a way that doesn't really make sense. You can keep it restricted to the Europe servers, the Europe everything, instead of having it run by whoever happens to be interested in calling the agent.
So really what we're talking about is privacy regulations or the regulatory environment in a particular region may dictate multiple books of record. I do know just similar to data sovereignty concerns, data for a particular region can only reside in a particular region. That probably is going to apply to agents also as we think about them being deployed across the enterprise, across various different regions. Now, I want to talk a little bit about what does this identity enable and what does it allow us to do? And in particular, I want you to tell me a little bit about how this identity allows us to create the authorization boundary and then the execution boundary. So tell us how we can actually use this agent identity. And this may be a little bit of a setup for the next set of episodes, Davis, but walk me through first, how do we use this identity to create that authorization boundary?
So you use the identity to create an authorization boundary by effectively attaching things to that identity. For example, in order to access a database, there is a set of credentials that are going to be needed. And you can create a set of credentials with the relevant permissions for this agent and attach it to that agent's identifier. And in that way, the agent can access these credentials and use them to get access to the database. You can attach all sorts of credentials here to whatever systems you need. But you can also do things like, say, making sure that these grants are given to the agent on an as-needed basis. Especially if you're operating in a headless mode, you know what the task is going to be executed going to be because whatever system is dispatching it has the task description in front of it. So you can effectively say, this task is going to require these 3 or 4 tools, or potentially require only, say, a third of the tools the agent is actually could theoretically use for all tasks. And then you can give it a grant that'll give it a very short-term ability to access only those tools it's actually going to need. And this lets you effectively only authorize the agent to do the things it's going to need to be doing right now, which helps cut down on the agent's ability to go off on a wild tangent and start hallucinating because it simply doesn't have the tools to actually do those things. If this particular task doesn't need a database, you don't give it the database tool at that time, and it's not going to start hallucinating database columns without the ability to, access a database.
Absolutely. So what we're talking about is, and I know we do this already, but when we package, for example, Claude Code, a very, very powerful agent, the typical pattern in the coding agent motif is that agent runs under a user's identity and all the permissions and access to that. When we actually package Claude Code inside a Docker container, we can actually take away bash access, shell access. We can take away internet access, and we can replace it with our set of tools, governed tools or governed skills that it's allowed to use. Is that, did I get that more or less right?
Yes, that's generally the way you're going to implement something like this. You have a set of governed tools, and then you only let the agent use those tools or those skills. You don't let it use overly broad tools like, say, bash that let it execute arbitrary code. You don't let it have these sorts of things because those will let it escape the boundary. Like, even if it doesn't have access to a database, an agent with access to bash could just write up a Python script that accesses the database and then run it. So you take away those tools, you give it only the ones that can do exactly what you want, and that effectively limits the blast radius in case something goes wrong, but you're no longer dealing with anything arbitrary could go wrong. You're limiting yourself to, it could potentially use these small set of tools in a way that's somewhat incorrect, but it can't do arbitrary things anymore.
Correct. Now let's extend to the third part of the series, which is the execution boundary. Now, today, these coding agents, and the default operation, by the way, is even if you were to restrict the tools in the way that we mentioned, what ends up happening is those tools are local. Now, anytime a tool is local, if the agent does something incorrectly, or there's a prompt injection or something like that that allows the agent to do things incorrectly, that tool residing locally is a security exposure. We can actually eliminate that security exposure by having tools execute remotely. They get executed in a tool executor that is a governed execution capability. When I say governed, it's secure, it's monitored. Only tools that have been verified are actually in that execution boundary. Is that what you're talking about as we move forward, Davis?
Yeah, that's more the execution boundary, the authorization. But yes, that is definitely a way you can secure these tools. Because if they're residing in the agent's directory, there's a limit to how much you can stop the agent from accessing them. On the other hand, if you wrap the agent in something that makes these tool calls remote, going to another machine, then you can have that tool execution service actually check and validate that the agent's grants are still valid, that they actually give it access to the tools it says it has. And you can control this on a much finer grained level than just whether the agent actually has these tools or not. And this way you can actually ensure that this thing is enforced. That even if something goes wrong with the agent, because it's not doing things on its own, it is still safe. These grants are still being respected.
Now, it strikes me, and I'm going to wrap this up and ask for your opinion on this, but let me set this question up a little bit. We've talked a lot about this as mandatory for agents, headless agents that are participating in business processes. How applicable do you think this is to securing these coding agents or personal agents? Does it make sense? Is it practical to actually be able to apply the same level of rigor? Now, let me put one thing off the table. I remember back in the day when we were building APIs, the very first time we built it, this is very early days, we would use inside the enterprises HTTP, no HTTPS, mostly because it was extra work. And then when we got that figured out, some folks wanted to introduce role-based access control using OAuth 2. The first reaction is far too much work. But ultimately, the security constraints in the enterprise override the potential one-time challenges in setting this up. So, long story short, here's the question. Do you think these techniques can be and should be applied to coding agents over time?
With coding agents, there's always going to be a trade-off between how easy it is to use and how secure they are. For an individual developer, there's always going to be the temptation to just use the coding agent's full power out of the box. And it's very convenient right up until it does something terrible to your production database. And as you get into more and more secure enterprises, going from like small startups to established corporations to things like banks that need the absolute highest tier of security, there's going to be less and less tolerance for this sort of convenience and the associated risk. So if you're operating in a highly secure enterprise, like you're going to need this sort of security in order for the enterprise to even accept the use of these coding agents in the first place. They're going to need a way to say, okay, I have a log of every command, every tool call that's been run by this agent. I have a record of its usage, how much it's costing me. I have the ability to say no, to reject these permissions if something goes wrong. I have the ability to verify that all of these permissions are actually enforced. And these sorts of techniques are going to be the sort of thing these enterprises want. They're going to want the agents running on, say, VMs they control in their own cloud that the developers are accessing, because that way they can, say, control the configuration of that agent rather than letting the developer put in whatever they want. It's going to let them control what data it has access to. It's going to let them control what tools it has access to in a way the developer cannot change. And while this does come at the cost of convenience, the added security is what makes it possible to use them at the scale you're going to want them in these large, heavily secure enterprises.
Well, Davis, thanks for that answer. That was great. So why don't we close here? We had this entire session. This is the first of 3 parts. This one is on agent identity, and hopefully you, the listener, have been able to identify, what is an agent identity, why is it important, and how does it fit into the bigger picture? The bigger picture being the authorization boundary, as well as the execution boundary. And Davis gave you some pretty good insight around how each of those fit together. But we're going to do a deep dive in our next session around the authorization boundary. And then after that, the execution boundary. So hopefully you found this useful and entertaining, and we're looking forward to you listening to our next session. Thanks a lot.